Hello, welcome to this week's Innovate Queensland Grid webinar for Giving Research and Ideas Direction. My name is John Matthew from Impact Innovation Group, and we will deliver the Impact Innovate Queensland program, which supports the Queensland Government's Advanced Queensland initiative. Today we have Dr. Sue Keay, Chief Operating Officer of the ARC Centre of Excellence for Robotic Vision. Dr. Sue will go through many of the findings from the Robotics Roadmap for Australia, due to be launched on the 18th of June, about the current state of robotics in Australia and where these technologies are heading. Just while we are waiting for other people to connect into the webinar, I'll go through some of the tools we'll be using for those people who haven't viewed a webinar with the Citric GoToWebinar system before. Your screen should look like this: a slide in the center and a control panel or dashboard on the right. This control panel will collapse automatically when you're not using it. So to keep it open, just click the View menu up the top and uncheck Auto Hide Control Panel. During the webinar, we may ask you a question so we can better understand your experience with the topic. We'll ask you to raise your hand, and to do that, just click on the little blue hand icon on the side of the control panel. Remember to lower your hand afterwards, just by clicking on the icon again. There's also the opportunity for you to ask questions. So the webinar can flow smoothly and we stick to the time allocated, we'd prefer to answer questions at the end of the webinar. But please feel free to ask questions as they come to you. You can also use this function to let us know if there's any problems occurring with the software. We also have some handouts for you, which you can access and download by clicking on this section here. Now, in a moment, I'm going to hand the screen over to Sue. Recognized superstar of STEM by Science and Technology Australia, Sue is a trained scientist with highly developed business skills who runs the world's first Robotic Vision Research Centre. The Australian Centre for Robotic Vision, headquartered at QUT, has more than 200 researchers distributed across Australian and overseas research institutions. Sue has been working across sectors to develop Australia's first robotics roadmap, highlighting how advances in robotics will impact on every sector of the Australian economy. So Sue, welcome to the webinar.
Thanks very much, John, and welcome everybody. This is actually my first webinar. I think this is a great initiative by the Queensland Government, and very big thanks to Impact Innovation Group for making this happen. Just to give me some sense of whether I'm on my own here, okay, would people mind raising their hand if they've been involved in some of these webinars before? Okay, so there's a few more people who have a bit more experience with these than I do, so I'll do my best. I guess to set the scene, to give you a view of what the impact of automation might be on small to medium-sized enterprises in Queensland, I'll give you a bit of an outline of some of the work that we've been doing in developing a robotics roadmap here in Australia. And also, I'll give you a preview, and you're the first people to see this, of an unpublished report that we've recently commissioned that has a look at the economic impact of robotics and automation on Queensland. And just to set the scene, you might not be aware, but by the end of this year, China will have purchased 1/3 of the world's industrial robots. China is investing $100 billion in robotics at the moment, so that by 2020, it can be self-sufficient in the production of robots. So what does that mean in terms of how we look at robotics in Australia and in Queensland in particular? Well, I guess the first thing that we have found in having a look at how robotics and automation has impacted in Australia to date is that Australia is unfortunately lagging behind quite a lot of our peer nations in terms of the adoption of robotics and automation. Although we are doing a little bit above the world average, as you can see there, we have a robot population of 83 robots per 10,000 employees. But compared to a company like Korea, we're not looking quite so great. Now, one of the reasons that Australia hasn't maybe seen as much traction with robotics and automation is because of the structure of our economy. So unlike a company like Korea that has a strong electronics and also automotive sector, where you have a large number of industrial robots in play, Australia does not have those things. But what Australia does have is great capacity in niche manufacturing, which is actually really well suited to the application of robotics. So I would hope that in the future Australia can move up the rankings from 18th to actually show much better application. Because if you're not aware of it, and I guess after this we can share some links, there is a report by a group called Alpha Beta that was commissioned by Google in Australia, which suggests that there are significant benefits to be made by more application of robotics and automation in this country. And also, as shown in the slide, we can't expect for our standard of living to be maintained at our current productivity rates. So we know that our labour productivity has been pretty consistently at 1.8% over the last 5 years, and it needs to be at 2.5% for us to maintain our standard of living. Now, the main way that you can bridge that gap between labour productivity and overall productivity is by the application of technology, and robotics and automation are the key technologies that need to be implemented for us to bridge that productivity gap. And as I mentioned, we know that there's quite a lot of productivity benefits if we are to employ robotics and automation. So the Alpha Beta report that I mentioned actually suggests that by 2030, it would be worth $2.2 trillion to the Australian economy if we're able to get this right. So I think that's something that we should all be interested in, and how we are able to do it. For people who are in the manufacturing sector, and I'll discuss the impact on jobs a little bit later on, but in general there is some good news for some sectors. By applying more robotics and automation, it's actually predicted that will increase employment in sectors like manufacturing. PricewaterhouseCoopers, or PwC, has done a survey of CEOs to see how they generally feel about robotics and automation. And of those CEOs that have introduced robotics and automation, they feel confident that it has increased their productivity. There are forecasts that it will, yes, increase our GDP. And I guess on the downside, though, when people are surveyed about their reasons for introducing robotics and automation, 58% of CEOs say that they have thought about it as a way to reduce headcount. So that is something that we have to be sensitive about in these discussions about whether robots will cost people's jobs, whether or not they do or don't. The fact that people are looking at deploying robots and automation to reduce headcount is probably going to be a fairly contentious social issue. Interestingly enough, from some of the anecdotal evidence we have from Queensland manufacturers, is that often while people look to deploy robots and automation to reduce headcount and reduce costs, in reality, what they find once they've introduced robotics and automation is that they increase headcount, but at the same time, they're increasing their profitability. So it balances out, and that's not a bad balance to have. The other benefits that sometimes don't get appreciated about the application of robotics and automation are the fact that it can make jobs safer and more satisfying for people. And as someone who works in a robotics lab, I can say with complete certainty that no one here comes to work with the intention of creating robots that are going to be taking people's jobs. The main reason that people look at developing robots is so that we can replace jobs that are considered either dirty, dull, or dangerous. So arguably jobs where it would be preferable not to have people working. And Alpha Beta has done a recent study that suggests that the introduction of robotics and automation can reduce workplace injuries by 11%, and that many occupations could be made much more satisfying to the occupants of those occupations than their current roles. Obviously, a lot of CEOs are thinking that robotics is going to help bring innovation into their business and will increase revenue. And hopefully we will see that robotics and automation will bring new and exciting opportunities while reducing the repetitive tasks that we often call on people to do. And the other interesting thing is that, I think the time is quite right for the introduction of more robotics and automation, because people are generally positive in their view of robotics at the moment. And I guess as someone who is in the robotics field, that is something that we will hope that we can maintain. For Queensland in particular, the benefits are likely to be productivity improvements. Maybe counterintuitively, another benefit will be the emergence of new jobs, perhaps more jobs. And we already have evidence that the introduction of robotics and automation is reshoring work back to Queensland. And I'll go into that in an example a bit further along. In the short term, it is thought that mining and agriculture, including food technology and hospitality and tourism, could be the sectors that will see the most impact of robotics and automation, with the medium to longer term seeing more impact in manufacturing. And that might seem counterintuitive, because in manufacturing we've had robots for the last 70 years. But on the other hand, I think the change in robotics is why we'll see medium to longer term benefits in manufacturing. At the moment, manufacturing already has a reasonably high infiltration of robotics, but robots and robot technology is changing rapidly. And so it will have quite an impact, even if a sector has had robots for some time. Now, apologies if this slide is a little bit fuzzy, but this is a preview of an unpublished report which has a look at the economic impact that the introduction of robotics and automation is likely to have in Australia, well, in Queensland in particular. And, Queensland does have its own unique economy, and this might not come as a surprise to you, but, small business is a dominant employer here. And by small, that is less than 20 people in the business, medium businesses 20 to 100, and then the large businesses over 100 people. And that's important because the fact that we have so many small businesses in Queensland provides a lot of challenges in how we're going to deploy robotics and automation, because it's highly likely that those businesses will not have the robotics or automation or integration specialists that will be required to successfully deploy robots and automation in their business. And that will be a big challenge. So again, this is from the not published yet report that we have had done on the potential economic impact on Queensland. And really what it is showing is the different sectors and their potential, the potentially disruptive influence on employment within those sectors, depending on whether the tasks are considered routine or non-routine. So the different colours that you see there in the graph on the left are really giving an indication of how automatable the skills in those particular occupations are. So you can see that the least likely to be disrupted at the moment is considered to be health and social assistance, although I'm not sure that this separation between routine and non-routine fully takes into account what social robots can now do. But let's just go with what this particular study shows at the moment. But basically it is suggesting the different occupations and which ones are most likely to be impacted by robotics. As you can see, manufacturing and agriculture at the top. Construction, health and social assistance considered to be some of the occupations that are less likely, although you can see construction has quite a large amount of routine manual activities. So the potential disruption in a sector like construction could be significant. And I guess one observation we've made in doing the Robotics Roadmap for Australia is that robots have gained traction in many sectors, and Australia has some fantastic examples of the application of robotics and automation. But it is very much dependent on the sector, and that sectors are at varying degrees of maturity in terms of how they deploy robots or how they have taken on automation. So manufacturing obviously is leading at the is at the forefront of the introduction of robotics and automation, but transportation and particularly logistics also have very mature technologies associated with them. And in a lot of the other sectors, it's still at the experimental or just trial stage. And so it is interesting to see the different rates that different sectors are adopting these technologies. But one of the key findings, I guess, from our roadmap is how important it is for the sectors that are at that experimental stage to really learn from the sectors that already have mature acceptance of the technologies. And I'll go into that as we move through the webinar. Just to give you a little snapshot of the robotics industry in Australia, because I don't think it's been very well, I'm sure that it hasn't been well defined before. One of the reasons that we started doing this roadmap was because we were interested in finding out who our stakeholders were in the robotics and computer vision industries. And we found that unfortunately there is no yellow pages for companies that fall in those industries. They really are often categorized under different sectors. Some of the companies, it might just be one part of the company that specializes in automation or robotics. And so it was very hard to get some real numbers on what that sector looks like in Australia. But it's important for us to know that, because what is our capability here in Australia? Are we going to be reliant on other countries to import our technologies, or how much of the technologies that we need to deploy robotics and automation in our businesses do we actually have here in Australia? And what we were able to find was that we probably have, at least 1,200, certainly more than 1,100 companies here in Australia that in some way specialise in robotics, automation, computer vision, sensing, that we believe that they employ far more than 50,000 people. And that we really conservatively estimate that that's probably worth about $12 billion to the Australian economy. Now, why that's important is that until this sector really gets recognition in its own right, it's very hard to argue for any sort of government support or even in any venture capital investment in the sector without us being able to define how large it is and what sort of impact it can have on the rest of the Australian economy. And one of the great things through the process of putting this roadmap together were how many fantastic examples we were able to find of things that were happening in Australia that were either the first time these things had happened in the world or were really just great examples of Australian ingenuity. So some of those are given in that infographic on the right of some of the really world-class, often niche applications that Australia has developed in the world of robotics and automation. And these are just some pictures that give some examples of some of the great companies that have developed and are doing really cutting edge stuff in the robotics space. So on the left, probably everyone's aware of the fantastic work that Rio Tinto is doing in terms of using driverless trucks to haul material from place to place within mines. There's a picture of the Pirates of the Caribbean. That's the XM2 crew. We have thousands of drone companies in Australia. XM2 happens to specialise in both cinematography but also asset inspection, and has developed their own drones to be able to provide that service. We have a company called Owlbot, which develops its own telepresence robots. Marathon Robotics is a company in Sydney that develops targets for military training practice, because unfortunately often our military personnel never get the opportunity to practice on moving targets until they're under live fire, and this is a way of combating that problem. In the middle is a Queensland company, Swarm Farm, that has been developing agricultural robotics for help in reducing the number of weeds in agricultural production. On the left is Fast Brick Robotics, which is a West Australian company that has been listed on the Australian Stock Exchange, which is essentially a bricklaying robot. And we also have some amazing stuff happening in the computer vision space. So down on the right is a company in Sydney called Ocular Robotics that develop a robot eye. And we also have a company called Seeing Machines that started in Canberra that develops technology that will assess whether drivers are fatigued, and do that all purely using vision-based techniques, and that's being commercialised at the moment. So we've got some great examples of things that we can be really proud of in Australia that are happening right here that hopefully our local small to medium-sized enterprises can access. So these are some projections of what it's going to mean for Queensland if we do apply more robotics and automation. So I will have to explain these graphs a little bit because they are a little bit out of context. On the left were some projections of what might happen if robotics and automation were introduced at different rates. So on the far left where it says 1%, that's if robotics and automation were introduced to the level where it would give a 1% improvement in productivity. Then in the middle, it's 1.5% improvement, and on the right is a 2% improvement, which are all fairly conservative estimates. But the graph that's on the right is about what that impact might have of those different rates of automation and robotics acceptance in terms of jobs. And what they found were that while the more you automate, the more jobs you displace or essentially lose, it also correlates with the creation of far more new jobs. And so in the far right is really an estimate of, at different levels of automation, how many new jobs you're likely to create. And I suppose the good news, although it's a bit counterintuitive, is that actually the more and the faster that we can introduce robotics and automation in Queensland, actually the better it's going to be in terms of creating jobs and also creating revenue. So I've outlined why this is important, not just to Queensland, but also to Australia, and how hopefully it's going to really change a lot of sectors, how we also have a lot of capability here in Australia, and I guess a lot of great news that we should be proud of. So if we've got all this great stuff happening, like where are all the robots? This picture is taken from one of the most modern car manufacturing plants in the world, the Tesla car manufacturing plant in Fremont in California. And they have some amazing robots there. They're all, worth more than $1 million, and they're given inspirational names like Colossus and Wolverine. But if you were to have visited a car manufacturing plant back in the 1960s, in a lot of respects, the scene that you would have seen might not have been so different from what you see here. The factories might not have been quite so polished, the robots not as impressive, but the one thing that you would have seen in those factories that you still see today is that you don't have people working anywhere near those robots. And that's really been something that's been holding back the application of robots in any business. That is the fact that in a lot of situations, like in car manufacturing, you can see that those robots are caged. The robots are not safe to have near people. If the robot is programmed to move something from point A to point B and someone gets in the way and it's an unexpected interruption, the robot has no capacity to change what it's going to do. So a lot of the work of our research centre here is about how we can change that. And the reason that that's important is because apart from in those very expensive manufacturing plants where, the robotics is really only accessible by people with pretty deep pockets. So those are the big automotive manufacturing companies. And that's because you can completely design your factory around your robot. What about in situations like agricultural construction, where every site is unique or has its differences, where you can't easily separate out the people from the jobs that need to be done? How is it that we can make robots operate in environments that are unstructured and where things could be changing at any minute? Because we need robots to be able to operate in those environments in a safe way so that if people do enter into those scenes, that they're not at risk of harm. Just to give you a bit of a background on our centre, we've been funded from the Australian Research Council, and the Centres of Excellence program is the largest investment that the Australian Research Council makes in non-medical research in Australia. Every 3 years or so, they fund maybe 10 Centres of Excellence, and it's quite unusual for them to fund a Centre of Excellence in technology. So our Centre of Excellence is very unique in that regard. And the Australian Research Council is really looking for areas where they think that Australia has some niche capability. And the value proposition we put forward was the application of computer vision to robotics. As you can see, we're made up of 5 Australian partners. We're headquartered here in Queensland at QUT, and have partners across Australia, but we also have international partners that we link in with to make sure that we're doing cutting edge material. But even though we started in 2014, to date, we still are the largest single collection of robotic vision researchers. And that's our aim. Our aim is to create researchers who, and we will graduate more than 80 PhD students through our life. And these are people who aren't just specialists in robotics, but are also specialists in how you apply computer vision to robotics, which we term the new field of robotic vision. And why am I telling you all of this? It's because robotic vision, we think, is really the missing piece, which is why you don't see as many robots out and about as you might expect. So we've had R2-D2 and C3PO on our movie screens since 1977. And yet, I guess people often wonder why we're not seeing robots like that out in the real world. And the reason is because our robots don't see. By applying computer vision techniques to robots, we can change that. Vision is an extremely important sense for humans, and we have reason to believe that it's equally important for machines. To date, the reason that we haven't seen a lot of computer vision used in robots is purely because we didn't have the computer processing power to be able to take advantage of all the vision data that could be supplied from cameras. And yet cameras are a fantastic sensor. At the moment, they're really cheap, and you get very rich information from cameras that you don't get from things like laser rangefinders, which really can only give you a 3D sort of sense of the world around you. Just to give you an example, and I apologize, I can't show you videos of our work just because of the fact that this is a webinar and it tends to slow things up. So I'll try and explain it through pictures. And this might seem like a left field example. This is an environmental robot we call our crown of thorns starfish robot, or COTSpot. And the aim of this robot is to reduce the number of crown of thorns starfish on the Great Barrier Reef, because unfortunately crown of thorns starfish are a predator to the reef. They eat coral, and because of their excessive numbers, unfortunately they are significantly reducing the coverage of the Great Barrier Reef. I think they're responsible for 20% of the destruction of the Great Barrier Reef. So we need to find some way to control their numbers. And while you might feel that an environmental example might not necessarily be 100% relevant to your business, I guess often when we have people touring through our labs here, we find that people can intuit from seeing how we are using computer vision and robotics in a situation like this to really imagine how it might be used in their own business. So I encourage you to do the same. So this robot was developed because we have a clear problem that needs a solution. At the moment, the only way to reduce the number of crown of thorns starfish is for a human diver to go into the water and to inject every single starfish. So you can imagine that that is a fairly limited approach to solving this problem. We're lucky that there is a toxin that can be used. It was developed by James Cook University. It turns out to be as simple as injecting the starfish with vinegar, which attacks the protein structure of the starfish and causes them to die. But the problem that we have is that it's only economic for our divers to go down and remove these crown of thorns starfish in areas where tourists go. So the Australian Marine Park Tourism Authority actually funds for human divers to go down and clear areas of the reef where we expect tourists to be, and the rest of the reef is being laid to waste. And so this is a perfect, I suppose, problem for a robotic solution. And so our lead researcher, Matt Dunbabin, developed this underwater robot. He put GoPros on human divers to see the technique that they used for injecting the starfish. He modeled an injection system based on that technique. But one of the single biggest things that has had an influence on our work since we started in 2014 has been the introduction of something called deep learning. Now, deep learning is the way that robots learn. And it is, I guess, trying to give robots some more of the flexibility that people have to learn things, not by being programmed to learn them, but to learn them from experience, either from their own experience, from people's experience, or from the experience of other robots. And so you can imagine that the Great Barrier Marine Park Authority were pretty sensitive about us taking a robot like this up onto the Great Barrier Reef. They wanted to be 100% sure that if we were injecting things on the reef, that we were only injecting these starfish. So how did we make sure that we could guarantee that? Well, the way that we did this and the way that some deep learning techniques developed is by training the robot through pictures. So first the robot was shown lots of pictures like the one on the left of the crown of thorns starfish, and it was shown thousands of images of crown of thorns starfish, which interestingly enough had to be labelled first by a human. And then the robot was showing YouTube videos of crown of thorns starfish. Matt then 3D printed plastic crown of thorns starfish, which he hand painted at home, put lead weights on them, threw them out into Moreton Bay so we could do some local underwater testing. And then eventually, once the robot had been sufficiently trained on crown of thorns starfish, it was taken up for trials on the Great Barrier Reef. What you can see in the foreground there is the robot injecting crown of thorns starfish, but also our vision algorithm in action. So we have developed vision algorithms that will identify the crown of thorns starfish and identify it so well that actually it learns as it goes. So now it's clever enough to know that a plastic crown of thorns starfish, like the ones that we 3D printed, is not a real crown of thorns starfish. It's also clever enough to be able to identify crown of thorns starfish even if those crown of thorns starfish are covered by coral or are in crevices which are hard to see, because that's important. It's important that you don't leave behind any of the starfish if at all possible, or you're really not going very far in terms of protecting the reef. But the reason that that I'm describing all of this is because this robot is a really good example of the benefits that you can get by applying vision to a robot. So this robot is 100% vision guided. It uses its vision to identify the target of its mission, which is the crown of thorns starfish. Once it's identified the crown of thorns starfish, it then has quite a complicated has to go through a complicated procedure of making sure it's in the right position. It might have to fight the current to maintain its position so that it's in just the right position so that it can apply an injection. And then it also has to keep its own onboard map. And as you can imagine, these robots are operating underwater. You can't just it's inaccessible to GPS, so it has to be able to find its own way around. And it does this completely based on the information that it's getting from its cameras. And so it keeps an onboard map. It recognises where it has seen crown of thorns starfish. It recognises which ones it's injected, which is important because it wouldn't be very helpful if the robot went and injected the same starfish 200 times. And it also recognises where it's been travelling. So it finds its way around by dead reckoning. So if it knows that it's gone 10 metres north, it just adds that to its internal map. Every now and then it will go to the surface to see that if it can get a GPS reading, in which case it will, just compare that with its onboard map and make sure that it's in the right spot. But one of the key things about using vision has been that it has meant that the cost of this robot can be kept very low. When this robot was first developed, in parts alone, it cost about $70,000. But one of the main parts of that cost was something called a Doppler velocity log, which is a way that you can tell whether the robot is, how far beneath the surface it is. But we actually found that we didn't need that. Vision can accomplish that. And so we can now produce these for less than $5,000 a robot, which means that then we can hopefully get them deployed much more widely. But I use this as an illustration to show you the sort of things that you can do when you have a robot that is guided just by vision. And an example where this is where robots are really being used a lot is now in logistics. So if you haven't seen something like this before, this is what an Amazon warehouse or fulfillment center looks like. The orange robot that looks a bit like a Roomba vacuum cleaner robot there in the picture is one of their robots. Amazon is actually one of the largest robotic companies in the world. They purchased a company called Kiva Robotic Systems maybe 7 years ago for almost $750 million. And they use these around all of their fulfillment centers. So essentially what happens is you might see that there are QR codes on the floor there. the robots know where everything is on the different shelves. They also know where the other robots are. The robots actually move in underneath the shelf that they need, and then they actually jack themselves up so that the legs of the I've lost the word for it. So you can see that it's lifting the shelving up so that it's not on the floor, and then it can transport that shelf to wherever it needs to go. What that means is that they've been able to completely redesign their warehouse so that they actually don't need a person to enter into this environment where the robots are at all. So the only time that Amazon uses people in these environments is to either put material on the shelves to stow items, or at the end of the process when the robot is needed to pick items off those shelves. So typically a person will stand in one spot in the warehouse and robots will come past with the items that constitute an order. The person's role is to pick the item off the shelf, put it in a box, then the next shelf will come past, or a robot will come past with another shelf. The person will pick the next item off the shelf and put it in a box, and so on until the order is complete, and that's what you would get if you ordered something from Amazon. So we applied our robotic vision knowledge to compete in something called the Amazon Robotics Challenge. We developed a robot called Cartman, which is short for Cartesian Manipulator Robot. And you can see this robot, it operates a bit like an arcade game. So it's a very simple robot. It can operate across 3 coordinates, left, right, up, down, and it can use either a 2-finger gripper or it can also use a suction gripper, which means that it can actually pick up different items. Now, this is a real challenge for a robot because unlike a human, robots have nothing anywhere near as sophisticated as the human hand. So while it sounds like a very simple task for someone to reach into a shelf, to pick something out, to identify it, to pick it out, and to put it into a box, that's a very complicated task for a robot. Now, in this competition, Amazon also allowed teams to design their own shelving system. In this case, it was more efficient for us to have a shelving system that's on the floor. So for a human, you would want to have a shelving system so that you're not having to reach down low all the time. That's not a restriction that you have to place on a robot. But what is difficult for a robot is having the dexterity to be able to navigate its way around through shelves. So hence you have the open top shelves that are sitting on the floor there. Now, Amazon didn't make it easy. They would make sure that those boxes were completely full of different items. So we had to be able to make sure that the robot was trained sufficiently to be able to recognize that if it couldn't see an item, it was quite possible that the item was hidden. And that it might need to move it out of the way. But we were successful at winning the Amazon Robotics Challenge last year, and that was largely due to the computer vision techniques that we had developed for this particular challenge. So one of the things that Amazon did, and this is really a key to what we need to see happen before we will see robots much more commonly in the workplace, and that was we had to develop, Amazon gave each team 45 minutes before they competed 16 what they call unseen items, which meant that you hadn't had an opportunity to train your robot in what they look like. So I described how the crown of thorns starfish robot worked and how we gave it thousands of images to train it up so that it could reliably make an identification. And we only had 45 minutes to do the same thing during this competition on 16 different items. So using computer vision techniques, we developed what they call a few-shot learning solution. It meant that we only had to take a couple of photos of each item, hand annotate them, and that was sufficient for the robot to be able to reliably identify that item. This is exactly the sort of thing that we need any robot that's out in the wild with people to be able to do. So a self-driving car, for example, is not very much use if it's not being able to recognise traffic signals and other things, or be able to cope with unexpected events. So that's sort of where we're heading. With a lot of the computer vision, the ultimate ideal is to be able to go to what they call zero-shot learning, where you don't actually have to train the robot up at all. It will intuit from what it already knows about the world the most likely use or the most likely label that it might need to put on something. But I'm just giving you this as a bit of a glimpse into, I guess, the future of robotics. So some of the things that we would expect that robots will be capable of in the near future, but we're not there yet. Another area of robotics that I think is quite overlooked is in the area of social robots. So the robot in the picture here is Pepper Robot, and it's developed by SoftBank Robotics, a Japanese telecommunications company that is now branching into robotics. And it's not commercially available here in Australia, but if you were to travel to Japan, you might have already met a robot like Pepper. And Pepper's sole function is to interact with people. So you can see Pepper actually has beautiful hands, but Pepper can't pick anything up. Pepper uses those to gesture. So in much the same way that we use our hands to communicate with other people, Pepper uses hands, body motion. Pepper will look at you. Pepper can recognize faces, will actually listen out for what you're saying, depending on how Pepper is programmed or whether we have Pepper linked to an artificial intelligence. Pepper can respond to unstructured conversations. But the entire purpose of social robots, is to interact with people. And I think that people underestimate the influence that these robots are going to have on different businesses. So we don't see them in Australia yet, but if you, as I said, if you were to visit Japan, you would probably have seen these robots operating in a fairly restricted fashion in restaurants or in hotels. So you could put a robot like this as a concierge at a hotel reception desk. You can have it understand 75 different languages, so that if you're new to the country, you're not reliant on finding a translator or someone on the hotel staff who happens to know your language. And you can program the robot so that it can answer a range of questions that you would typically find if you went to the front desk of a hotel. Where's the nearest bus? Can you call me a taxi? All of those sort of things. So that might sound like fairly limited applications. But what we're trying to do with a robot like Pepper is to give it some of that vision capability that I mentioned, so that we could see it used in an area like healthcare, for example. So we would like to apply our scene understanding and computer vision techniques, so that you could imagine a robot like Pepper doing rounds in an aged care facility, and Pepper would be able to make intelligent decisions based on the visual information and cues that it receives. So you can imagine Pepper coming to somebody's room, making an observation. Well, are the curtains closed? Is the person lying down? Is the person asleep? Well, maybe it's not a good time for me to interact with them. For Pepper to understand, well, okay, the person's asleep, but it's midday. The person's not normally asleep at that time. Maybe I need to, alert someone that there might be a problem. Pepper could also understand from the visual data that maybe the person's lying down, but the person's not on the bed, the person's on the floor. Well, that's clearly a problem. So, we know that in aged care, for example, that people receive 88 minutes less care per day than is recommended. And we think there are a number of ways that a social robot like this particular platform could actually help support our healthcare professionals by either giving public education messages, doing the rounds, checking that the patient remembers information that the doctor gave to them that morning, for example, checking that they're taking their medication, that they're eating their food. The range of possibilities is quite long, but at the moment when we don't quite have the technology there, but it's through these computer vision techniques that we will get the technology to the point where you will start to see these robots much more commonly in what I call front of house functions. So it's not uncommon for us to have robots like the ones you saw at Amazon in logistics, sort of doing back of house functions. If you ever get the opportunity to visit some of our new hospitals like Sunshine Coast University Hospital, they have a range of automated ground vehicles that transport all of the linen, all of the food, all of the different medical equipment. Even they have separate robots that even transport all of the medication around the hospital. But all of that's done largely out of sight. You don't necessarily see those robots or interact with them. The robots don't have to be particularly sophisticated because they don't really come into contact with people. But these social robots have to be different. They have to be safe to operate around people, and they also have to interact with people in a way that I guess people understand and appreciate. And I guess a couple of the final thoughts that I'll leave you with is just how fast technology can change. So this image here is just to show the difference between the first winner of the DARPA Grand Challenge in robotics in 2007. That was a challenge that was to see whether a team of researchers could get a vehicle to operate without a person over, I think it was a 98-kilometre long course. And you can see the huge number of sensors. If you have a look inside those cars, they were completely full of processing power. It was lucky that they didn't have to have a human driver, because it probably would have been hard to fit one in. In the space of 10 years, on the right is a picture of a current Tesla, which is essentially a self-driving car. Just needs probably a few tweaks before it really would be completely safe to have driving on our roads, if we could get regulations in place to allow that to happen. So in the space of 10 years, we've gone from what you see on the left to what you can now actually buy. So perhaps we will be seeing some similar changes in similar improvements in other robotic technologies. But going back to one of the things I mentioned earlier, which was the importance of trying to get this information from one sector across to another. And I don't know that it's a particularly Australian problem, but we do seem to have a situation where we can be world leading in automation in one sector, but other sectors may not necessarily be benefiting. And I guess that's partly because everyone defines themselves in terms of their sector, if you're a manufacturer or if you're a mining company. The advantage, though, is that if you are in different sectors, that you're not necessarily competing. And so as part of the roadmap process, we've actually found a couple of different companies who come together, who are trying to learn from the lessons that they have seen are being made across different sectors. And I think this is going to be extremely important. For a country as small as Australia, I think we need to be able to share this information across sectors as much as we can, or else it's going to be a struggle to maintain our competitiveness. So one example of this is a company called UAP, which is based in Brisbane. And they're using robotics for what they call mass customization. And they have used these to reshore jobs back to Australia. So just to give you an overview, UAP is a company, I guess you'd call it a construction or architectural firm. They build huge facades. In fact, if you've ever been to Brisbane Airport, as you come out of the airport and have a look at the car park, there is this sort of shimmering mass of metal on the car park, which is made by UAP, designed and constructed by UAP. So a lot of the work that they do is artistic. It's one-off creations, but they're large structures. And so, you know, they are working in to develop these things. They're, I guess you could call them part manufacturing, part construction company, but also with that architectural and artistic bent. Now, for them to design and build some of these structures, typically they would have, particularly if it requires a lot of panel beating, typically they would have sent that over to somewhere in China to have the majority of that work done, because it's very labour intensive, formally not easy to automate. But they are now deploying robots in their operations, because we're getting to the point where you can actually use robots to do fairly specialised one-off work. And you know that you don't have to just get them doing the same thing, moving something from A to B endlessly all day. And as a result, you know, the good news is that UAP has actually been able to bring a lot of the work that they would traditionally do in China back to their facilities here in Brisbane. So that's one good news story. I guess the other benefit is that UAP, along with the construction company Lang O'Rourke, have formed a collaboration with QUT to develop what they're calling a design robotics hub. And the whole purpose of this hub is to share knowledge and innovation, particularly among small to medium-sized manufacturing companies. So, you know, this offers the opportunity for people to actually go along and see how a company like UAP is actually using robotics in their operations, and I guess take lessons from there and see whether it would be feasible to do something similar within your own business. This is just to give you.
Just let me know, you have 10 minutes left.
Oh, okay. So yes, I'm almost at the end. So we're launching this robotics roadmap in Monday in Canberra. Some of the main recommendations, probably no surprise. We think that there are a number of things that could be done to stimulate robotics in this country. Uh, Obviously, making sure that Australians have Industry 4 relevant skills is critical to all of this. And I guess we all have a role to play in making sure that happens. Um, I think in talking about social robotics, I think one of the unexpected things that people need to be cognizant of is the potential impact that robotics and automation is going to have in front of house roles that people might not necessarily expect robotics to have an impact on. You'll have a copy of these slides, so I won't go through each of the points here, but they look like there can be significant benefits, particularly in Queensland, if we are able to automate or apply robotic technologies and apply them quickly. But it will mean that there will be changes to jobs. Some jobs will cease to exist, but fortunately a whole new array of jobs will be created. And I guess the insights I'd like to leave you with today are really that hopefully from some of the examples that you've seen, you might be able to ensure that a lot of businesses actually can be made more structured in the way that manufacturing is, so that you can deploy more robotics and automation. I guess it's a matter of rethinking processes and how you can take the advantage that robotics and automation can offer. I guess it's probably no news to anyone that automation is going to gain traction across all sectors, and like all countries, we need to be able to keep up with that. I think it's also important to recognise that automation is rapidly evolving, even in mature sectors. So even if you're in the manufacturing sector, the way that robots worked 20 years ago is quite different to the way robots work today, and everyone needs to have the skill set required to be able to keep on top of those developments. And I think we all need to plan for there being robotics and automation, and for there being quite a need for retraining of the existing workforce and helping them to adapt to the changes that robotics and automation will bring. So thank you very much for the time reminder, John. Just to finish off perhaps on a positive note, really, I don't know that many people are going into developing these new technologies with the idea that people will never have jobs in the future. There's a lot of evidence that robots alone actually don't necessarily operate very well. The best teams are formed by robots and humans. And I'm sure we can unearth some Australian examples, but at the moment what we do know from other countries is that, for example, in Germany, or while manufacturers deploy lots of robots, they also still employ more humans. And in the case of Amazon, in the same time that they've deployed 100,000 robots, they've also employed 300,000 people. So hopefully, we can get to the point where everyone can get behind deploying more robotics and automation in their business without having to worry about the consequences of the negative public backlash. So thank you for listening, and if you have any questions, please let me know.
Thank you so much for that, Sue. The technological advancements Australian have really experienced in such a short amount of time really speaks to the way in which every industry is innovating to maintain their position in an ever-evolving global market. We do have a few questions, but ladies and gentlemen, please feel free to ask them in the question section of your control panel there. We'll start off with kind of an interesting one. Are there any major legislations or that are hindering Australia from uptaking or adopting robotics on the same level that we've seen Korea doing so?
Yes. Interestingly, during the roadmap, it was interesting that sometimes we would get some fantastic examples of where Australia was leading the world, and then almost in the same breath, they were also the things that were holding us back. So particularly in the unmanned aerial vehicle space, Australia actually was leading the way in terms of regulation for quite a time. And we did have some of the first trials of Google's delivery system here. But very quickly, other countries like New Zealand kind of caught on to this. And I'm not sure I understand completely how this all evolved. But, a lot of people now will send their drone operators to be trained over in New Zealand. And also there are a lot more trials of technology happening in New Zealand and away from Australia. So I don't know. It's one of those things that I think we have to constantly be on the lookout for. There are certainly areas where Australia has actually led the way in the world. In fact, I think it's still true to say that our UAV regulations are much easier to navigate than in a country like the United States. But we can't be complacent. It's so easy for other countries to swoop in and I guess notice the advantages that we have and adopt them and then improve on them. But yeah, I think we need to, apart from the fact that Korea has a slightly different economic structure to us, so they have reasons that they are the world's number one robot density, have the world's number one robot density. But I think we can definitely learn from them. There's a lot more that needs to be done in that space. But I think, sorry, just to quickly finish off on that, one of the points of doing this roadmap is actually just to point that out to governments, because I'm not sure it's been clearly articulated.
That's a fair comment as well. Following up on that, you've touched on large-scale robotics in larger corporates and businesses like Tesla and Amazon. Could you just give an idea of what small-scale robotics would look like for a small business or a medium-sized business?
Yeah, well, it could be something as simple as a social robot that you could use as a concierge to answer questions, or it could be not. I mean, in our for roboticists, chatbots and artificial intelligence aren't really robots, but they are a very important component of automation. So it could be, robots that don't have a physical presence. So I think certainly the application of artificial intelligence to a lot of office functions is something that all businesses should be looking at doing. In terms of more physical robots that actually interact with their environment, it depends very much on the business and what are the benefits of doing so. But there are a number of different case studies that we found in Queensland of companies that perhaps you might not expect who are experimenting with robots, even though they are quite small in size. So I think the opportunities are there, but it's still very much at its early stages. So you would definitely be one of the early adopters if you were to progress with the use of physical robots. I think that in terms of chatbots and other technologies like that, that's probably much more well established.
Understood. Probably the last question for us here, but currently there are degrees in higher education offering for students for robotics and integrating that kind of systems into their learnings. But with established business owners and professionals nowadays, up in their 30s, 40s, 50s, 60s, is there any way to upskill established professionals in robotics?
Yeah, well, at the moment, I don't think there's a simple answer to that. But one of the key things, one of the key recommendations from this roadmap is that we need to be embracing micro-credentials. So, for example, I think the Queensland government has just announced that they are funding what they're calling an AI hub. Now, that's a way that as a business owner, you can go for a couple of nights a week to really get your head around artificial intelligence and figure out what it might mean to your business and how you might be able to apply it, or to send, one of your employees along to gain skills so that they can apply artificial intelligence. Now, that's important, but I think at the moment it conflicts with the current business models for our universities to be able to supply micro-credentials. But perhaps there's also something we can do in terms of TAFE. But otherwise, I think that perhaps we need to set up these separate entities like the AI Hub so that people can get those credentials and knowledge without having to go back and doing a whole 3 or 4 year degree. It's critical. But no, I don't think we have got that in place yet.
Thank you so much for that, Sue. Unfortunately, we'll have to end it there. Thank you everyone for attending the webinar today. Please remember to download the handouts before you exit and stay in touch with the Innovate Queensland via the GRID group on LinkedIn so you can find out about future webinars and events. The GRID program is about helping you with your implementation of innovation in your business. So we'll send you a short survey and use your responses to tailor the GRID program to meet your interests and needs. See you next time on the GRID. And thank you so much for everyone. And thank you so much, Sue, for donating your time.